Hello and welcome to the second section of Unit 8. I know it says 10 up here, but it's actually Unit 8. So in this lesson, we're going to talk about when we have exponents raised to another exponent. So over here, we have 3 to the 6th, all to the second power. So this time, today, we're going to have something on the outside of the parentheses. So whenever I have something squared or something in the second power, that means I'm multiplying it times itself 2 times. So 3 to the 6th to the second power is like saying 3 to the 6th times 3 to the 6th. So what we learned yesterday is when I multiply two things that have the same base, I add their exponents. So 6 plus 6 would be 12. So this would be 3 to the 12th. So notice, well, I'll do this one and see if you start to see a pattern. So 5 to the 4th to the third power means I have 5 to the 4th times 5 to the 4th times 5 to the 4th. So if I added up all those exponents, I get 5 to the 12th. And then over here, if I have a to the third, all squared, I'll have a to the third times a to the third, which would be a to the 6th. So hopefully you see the pattern that all we have to do is multiply these two exponents. So whenever we have something in parentheses and an exponent on the outside, so if I have an exponent on the inside and on the outside, I multiply them. Right here, I do not have parentheses, so I'm adding the exponents. Here I have exponent inside, exponent outside, so I multiply. So instead of writing g to the 4th out 5 times, I can just say, well, 4 times 5 is 20, so this is going to be g to the 20th. So see how that's a lot quicker? So in example 1, that's what the power of a property, that's what this is explaining, what we just talked about. So if I want to simplify it, a squared to the 4th power, oops, that's an a, I'll have a to the 8th, because 2 times 4 is 8. X to the 1/2, all to the 1/4. So again, I have an exponent inside, exponent outside, so I'm multiplying the two exponents. So fractions are kind of scary for a lot of us. So if I was multiplying these two fractions together, multiplying fractions is really easy, because all you got to do is multiply across. So 1 times 1 is 1, 2 times 4 is 8. So I'll have 1 on the top, 8 on the bottom. So the answer would be x to the 1/8. So example 2, so it starts to get a little more complicated here. So again, I have x to the 2/5 all to the 1/3. So I got an exponent inside the parentheses, exponent outside the parentheses. So that means I'm multiplying. So I'll have 2/5 times 1/3. So again, fractions to multiply and multiply across. So 2 top numbers, 2 times 1 is 2. 2 bottom numbers, 3 times 5 is 15. So x to the 2/15. And then I still have times x to the 3rd. So now we do not have any parentheses here. So we don't have something inside the parentheses and something outside. So that means what are we doing with the two exponents? We have to add those. So adding fractions is a little tougher than multiplying. So I got to find a common denominator. So if I have 2/15 and I'm adding 3/1, I need to make the denominators the same. So 2/15 plus 45/15, because if I multiply 15 times 1 and 15 times 3, I get 45/15. So 2 plus 45 is 47, and then the denominator stays the same, so 47/15. So our answer would be x to the 47/15. And then this next example, it's kind of hard to see here. Make this a little bit bigger. So x to the 3/2 is inside of the parentheses, 4 to the 4/5. That exponent's on the outside. So what do we do if we have an exponent inside and an exponent outside? We got to multiply them. So 3/2 times 4/5. 3 times 4 is 12. 2 times 5 is 10. If you want to reduce that to 6 over 5, you can, because 2 goes into both of these. And then I got x to the 1/3. So far we have x to the 6 over 5. And then x to the 1/3 to the second power. So again, we have x to the 1/3 inside, and then there's an exponent on the outside. So 1/3 times 2. 1 times 2 is 2. 3 times 1 is 3, so 2/3. So x to the 2/3. So notice we no longer have any parentheses. So what are we going to do? These are the same base. So we still got x as a base, so we still can combine these. But we can't multiply the exponents, we have to add them, because there's nothing inside and outside the parentheses. There's no parentheses at all anymore. So 6/5 plus 2/3. So in order to add these, I need common denominator. So what number does 5 and 3 both go into? Well, 5 and 3 both go into 15, I know, because if I multiply 3 times 5, it equals 15. So what do I have to multiply 5 by to get 15? Hopefully you're answering 3. So if I multiply the bottom by 3, I got to multiply the top by 3. So 3 times 6 is 18, and then 15 on the bottom. What do I need to multiply 3 by to get 15? Hopefully you're saying 5. So I multiply the top by 5 as well. 5 times 2 is 10. 3 times 5 is 15. So now we have the same denominator, so we can combine those two, or we can add them. So 18 plus 10 is 28. Denominator stays the same. So our final answer will be x to the 28 over 15. So we can use repeated multiplication to simplify expressions like 5y to the 3rd. So 5y to the 3rd, if the 5y is in parentheses, is the same as saying 5 times y, or 5y times 5y times 5y, so 3 times. So I can multiply these, so 5 times 5 times 5, and then y times y times y. So we get 5 to the 3rd times y to the 3rd. But another way to look at this to make it a little bit quicker, because that could take a long time, depending on what the exponent is. If I have something inside parentheses and there's an exponent on the outside, this exponent gets distributed to everything inside the parentheses. So don't forget, a lot of people forget to distribute this exponent to the numbers. Don't forget to do that. So that means I'll have 5 to the 3rd times y to the 3rd. So same thing we got up here. So if you wanted to multiply out 5 to the 3rd, you'd get 125. So 125 y to the 3rd. So moving on to the next page. So what we just talked about is right here. So you're distributing this 3 to each term inside of the parentheses. So if I wanted to simplify example 3, so this negative is going to stay on the outside. So first I deal with parentheses and exponents. So I have 2 squared times y squared. So 2 squared is 4. So when I have a negative sign, that's kind of like multiplication. So that's why I'm doing the exponents in the parentheses before I do this negative sign. So now I can distribute the negative, so I'll get my final answer being negative 4y squared. So same thing on this one. So I got a 2 on the outside of the parentheses. So that means everything inside of this parentheses will get the 2 in the exponent. So I have 7 squared, and I'll have m to the 9th squared. So 7 squared is 49. So notice we still have parentheses. So we got a 9 on the inside, 2 on the outside. They're both exponents. So what do we do with the 2 exponents? We've got to multiply them. So 49m to the 18th. So hopefully you remember that any time we have an exponent of 0, it always equals 1. It does not matter what the base is. So exponent of 0 always equals 1. As long as the base is not 0, of course. When we have a negative exponent, that creates fraction, so we always have to get rid of the negative exponent. In order to do that, we got to take the reciprocal or flip it. Once we do that, the exponent becomes positive. So in example 4, first thing we're going to do, since we have an exponent on the outside of parentheses here, every term, there's only 2 terms, but every term gets that exponent. So x to the 6th will have an exponent of 2. Y to the negative 3 will have an exponent of 2. So notice we still have an exponent on the inside and on the outside, or anytime we have an exponent going to an exponent. Even if there wasn't parentheses here, we have x to the 6th to the 2. We still have to multiply them. So x to the 12th times y to the negative 6th. But again, we do not want to leave exponents negative. So x to the 12th is a positive exponent, so that's going to stay where it is. But y to the negative 6th, we got to move that. Once I move it, since it's already on top, this is like divided by 1, same thing. If I move this to the bottom, it becomes positive. If we have a negative exponent on the bottom and move it to the top, it becomes positive. All right, so now, again, we got exponents on the outside of parentheses. So everything inside of those parentheses gets that exponent. So x squared to the 4th times y to the 3rd to the 4th. And then all of these get negative 4. So x squared to the negative 4 times y to the 4th to the negative 4. So x squared to the 4th. So we got exponent to another exponent, or inside and outside. So multiply them, x to the 8th times y to the 12th times x to the negative 8 times y to the negative 16. So anything that is negative, we need to move. So since there's nothing on the bottom, these are just going to get moved to the bottom. So x to the 8th times y to the 12th will stay on top. X to the 8th times y to the 16th will go to the bottom. Notice here, we have x to the 8th, x to the 8th. If I divide anything by itself, what does that always equal? That always equals 1. Or when you're dividing exponents, you subtract them. So x to the 8th divided by x to the 8th, it's like saying x to the 8th minus 8, which is x to the 0. And anything to the 0, power equals 1. So that's how I know that anything divided by itself is equal to 1. So these are going to go away because they equal 1. So y to the 12th divided by y to the 16th. So which exponent is bigger, 12 or 16? The one on top or the one on bottom? The one on top. The one on bottom. What's the difference between 16 and 12? Well, that'd be 4. So that means y stays on the bottom. The difference between 16 and 12 is 4. And then this one goes away, so I'll just put a 1 up there since there's nothing else. And then finally, example 5. So this m to the 3rd has an exponent of negative 1. So I got a 3 on the inside, negative 1 on the outside. So m to the negative 3, I got to multiply them. Again, 1/3 is the exponent on the inside, 1/4 is the exponent on the outside. So I need to multiply them. So 1 over 3 times 1 over 4. Multiply across, it's 1. 3 times 4 is 12. So that's x to the 1 over 12. So these two bases are not the same, so I cannot combine these two things. X to the 1/12, that's a positive exponent, so it's going to stay where it is. M to the negative 3 is a negative exponent, so I need to move it. It's already on the top, so I'm going to move it to the bottom. So m to the positive 3 now. So again, once you move it, exponent becomes positive.